Welcome to chapter 2. So, at the end of chapter 1, you should have realized that the amount of surface water added by the lake gave more water vapor, which caused more clouds, which then caused more rain. So, now we're going to look deeply into the other two claims in the upcoming chapters. Chapter 2, we're going to look deeply into claim 2, where we discuss warmer weather, and chapter 3 will focus on wind and other conditions. So, to get started, I want you guys to turn to page 40. And the question asks, which statement best describes how the sun heats the air? So, I want you guys to spend some time on this, think about it, and press pause, and when you're done, come back. So the answer to this question is A, that the energy from the sun is transferred to the Earth's surface, and some of the energy is transferred to the air. So we're going to talk about this as we move on. So I'm going to go back to this image that you guys saw in chapter 1. But I want to focus on the part that I've already have circled here in red, and is why is the amount of rain in Galetown different from storm to storm? So this is the chapter 2 question. We see that in storm 1, which you guys saw this in the last video, was mild, and after the lake, all of the ones after the lake there was high surface water, but they all had different amounts of rain, moderate, severe, and very severe. So it actually continued to progress. So we're going to focus on why are they different? So in the investigation today, we're going to look at what determines how much air a parcel will cool. And to find out more about what might be adding to the severe rainfall in Galetown, besides the lake, we need to have a deeper understanding of what increases rainfall. In chapter 1, we learned that rain can occur when the water vapor in the air parcel condenses. This happens when energy in the warm air parcel transfers to the cold surrounding air and cools the parcel temperature down. We also know that the more an air parcel loses energy and cools, the more rain can happen. But what determines how much an air parcel will cool? So we see here we have the yellow lines indicating that the energy is forming out or coming out of the cloud. So the temperature is going out until it reaches the same temperature as the air, which will then lead to it beginning to rain. So we're going to look at the sim activity. And if you turn to page 41 in your books, you're going to see... All right, guys, we're back at the simulator, and I'm going to go into Regional Weather 1. And what it asks us to change really is not the surface water. So I'm going to leave the surface water at the same temperature, but actually at the same level, and switch over to the temperature. The increase in sunlight or decrease in sunlight is going to change the temperature. And I'm going to start at 0. And I'm going to press run. And we see here that the temperature after warming is 15 degrees Celsius. And it actually doesn't go up at all. So it stays in the troposphere at 0 kilometers, so meaning that it didn't rise. And when I go to analyze, again, I'm going to get the same information. There wasn't much change. So I'm going to increase to 2 and see if that changes how our weather would react. And as the sunlight is hitting, we can see that it's rising above, and it maxes out right at 25 degrees Celsius. And then it raises up to 5 kilometers. So at level 2, it goes to 5 kilometers, and it raised to 25 degrees. So its max heat was 25 degrees when it was warmed, and its final height in the troposphere was 5 kilometers. And so let's go back, and let's even make it more dramatic. Let's go all the way to the end and see what happens then. So now we're increasing the sunlight, which will increase the temperature definitely. And let's look. It's going to end at 40. And now, as it goes up, with 40 degrees being its initial heating temperature, to 7.5 kilometers. And we also see that there's more rain than there was before. So we're going to go back to the slides and see if we can make some sense of the slide. And I have filled out the slide, and it says to look back at the table at the starting temperature of each air parcel and the final height of each air parcel. And what do you see as a pattern? And what you should see is that as the temperature increased, as there was more sunlight, which would mean that the temperature that was hotter, it went up, but so did the level of the height. So what we're seeing here is that the more something heats up, the longer it's going to take to cool. So it's going to go higher and higher in the troposphere so that it can release energy. And so a key concept here is that the troposphere is warmest at the point of the surface and coldest as it goes higher. So as you move up in the troposphere, it gets colder. So as the warm air parcel rises, it's going to rise until it's released enough energy to be equal with the air around it. So I'm going to show you guys a demonstration of this using a blow dryer, which would increase the hot air, and then trap the air inside of a bag and see what happens to the bag as it's released into a colder temperature outside. So I need you to turn to page 42 and make a prediction of what you think was going to happen, and then press pause and wait for the video. Well, press pause when you're writing, and then when you're ready, play the video. On the thing, and I'm gonna, can you tie it? There's a hole. You got a hole there.
I'll let it go to let you fly away.
Yep.
All right, ready? Let go. Okay, guys, so welcome back. So as we see in the video, in the demonstration, is that if an air parcel is warmer than the surrounding air, it will continue to rise. So this would mean that an air parcel will continue to rise until it runs out, until the thermal energy is released and the temperatures are the same. So we remember from the thermal energy unit that energy will continue to move until it is at an equal temperature. So if it's either a large air parcel or a much hotter air parcel and there's more thermal energy, it's going to continue to move up until it reaches equal temperature. Now 43 in your books, and again, you can always find the page on the top if you're lost. I want you to take a look at this hot air balloon, and it's like an air parcel, and explain why it rises. And I want you to also answer, if two hot air balloons are filled at the same time, but one is filled with warm air and one is filled with hot air, which balloon do you think will rise higher? And is there any way that those can switch? Explain your answer. You're going to be able to answer these questions in the document provided in this assignment. See you guys.